Jeremy, thank you so much for being here. You're a longtime friend of the company, and we really appreciate you coming.
Oh, it's always a pleasure. It's nice to get an upgrade to chatting to you after all these chats with Lucas.
He's watching. We'll see
Oh,
what
I
he
didn't
thinks about
say that, Lucas. Not at all.
Uh, so I want to talk about fast AI. I want to talk about MedARC, which is a new thing that you're working on. I want to
Hmm.
talk about what machine learning today in the world of large models and this and that looks like, and also like you've built one of the best machine learning communities out there. So I just want to
Thank
touch
you.
on that as well. Does that sound like a good set of
That
topics?
sounds great. Let's do it.
Cool. So let's start with fast AI. I love
Mm.
your mission. Like you want to make deep learning accessible to everyone. And now there have been these breakthroughs with like Stable Diffusion, ChatGPT 3, where more people are consuming models than training models. So does that influence your mission at all? And if so, how?
Yeah, it's tough, the the most flashy applications, generally speaking, are going to be the ones that use the most compute because by definition you do the same thing twice, one with more compute and more data and one with less. The one with more compute and more data is going to get better results. Um, and that often people often misunderstand that as thinking, oh, the research has to happen on lots of data and lots of compute, and I can't do good research otherwise. But that's not how it works at all. The research happens on much smaller data sets, on much smaller amounts of compute. The researchers get things working really well. And then the final step is the kind of engineering task of scaling that up once the research is basically done. Um, and so it's unfortunate that the research work tends to get a lot less coverage than that engineering step. So for example, um, my friend Wasim pointed out on Twitter yesterday that the actual research behind the clip model, that's the thing that allows us to type in a sentence and have it understood in a way that a picture can be then drawn of it. Um, the actual research for that was done in the medical imaging community, and that research has thousands of times less citations than CLIP, which actually simplified it and scaled it up to more data and basically reported, oh, here's what happens if we take this medical imaging insight and scale it up, or by the same kind of, I mean, not as much, but somewhat, my own ULM fit algorithm, which pointed out, look how effective it is to fine tune large language models. You know, OpenAI greatly scaled it up and switched it from a LSTM to transformers, and the result, which is GPT, got far more publicity than the original ULM fit and far more citations. So yeah, I mean that's just the nature of human interest, I guess. People are interested in the flashy applications and not necessarily the the research work that goes in behind them.
So how do we, I guess it's a big question, but like, how do we change the incentives of the research world to get that first clip paper to get as much attention or get people to at least like study that before they study the engineering version of it?
I don't know. I mean, it's not a big problem. Like in the end, the research gets done and people get grants and whatever else, and we don't do it for media attention. Like it's human nature. I think it's fine. I think the main thing that we try to do at Fast AI is to help people understand that they to become effective researchers, they're not really limited by compute or data the vast majority of the time. That impression is an accident of how things are reported, but it's not really the truth of how the vast majority of effective research is done.
That makes sense. And is it changing the things that you teach in the course itself? So, like, are you focusing more on like how to deal with like distributed compute and like these engineering type tasks, or are you still focusing on the research tasks for fast AI?
Yeah, no, I don't focus on the engineering type tasks because the vast majority of people don't need it the vast majority of the time. You know, that they again they get a lot of attention. Engineers love using lots of machines, so engineers always want to like be doing distributed computing or whatever. But I don't think that's where the vast majority of kind of impact happens. Impact happens when you understand the opportunities and constraints of a problem space and successfully figure out how to use, ML to do something in that space that's useful and wasn't done before. Um, so certainly the things I teach in the course, yeah, they keep changing, but they change to focus on like what's the most effective techniques um, for training and using deep learning. And they actually haven't changed that much. Our main focus has always been and continues to be transfer learning and fine tuning, which actually it's the opposite. I feel like the rest of the world is coming around to our way of seeing things, which is with things like instruction fine tuning and RLHF and the stuff behind ChatGPT. I think people are starting to realize finally, like, oh, maybe we should be actually taking notice of fine tuned models more than we have been.
What is the best way for ML engineers entering the field today to learn to interact with these large models? Is it like to learn to fine tune them? And if so, where would they learn about like what one, how to do it, and two, what's possible once they fine tune it?
Um, yeah, that's basically what our course is about. So they would do the fast.ai course.
Yeah.
We attack it from two angles. The first is a kind of applications first angle of how do you fine tune a vision or a language model for a task? How do you capture the data set for that? How do you deploy that as a web-based application? Um, and so that's part one of the course. And then part two of the course is, okay, well, what if you want to be a researcher, to be somebody who actually improves the underlying technologies? Well, in that case, you have to understand in detail all of the pieces. So we build all the pieces of Stable Diffusion back up from scratch, like literally just Python and its standard library, not even starting with NumPy. We build everything up from scratch. And so you end up recreating Stable Diffusion in its entirety, at which
Yeah.
point you obviously now deeply understand it. You write your own machine learning framework from scratch. So you obviously end up understanding that. And then I think that's helpful, when you want to go beyond, using well-trodden applications of fine-tuning in well-understood ways to doing things that maybe haven't been done before or doing it in new ways. You've got the knowledge you need to do that.
Um, I've always I took your course now years ago, but like I've always found it so fascinating that you cut through all this theory and you're like, here, I'll give you the minimal amount and you can start playing with the model and you change some hyperparameters and you can viscerally see how the model changes. Like, and I just love that. How did you come? But not everyone was like teaching machine learning like that. What about your experience in your life made you decide like that's how I'm going to teach?
I think it's, I maybe it's just I'm not smart enough to handle these super abstract bottom-up courses that they've never
That's
worked for me, you know.
yeah.
Um, and furthermore, I started trying to do them in undergrad at university. Originally, I wanted to do physics, um, but I just they didn't work for me. Start with like all this like here's a bunch of definitions and lemmas and whatever, and nobody ever says what it's for, and it
Yeah.
just didn't. Yeah, I kept on. I had so many questions, but the answers are always like, oh, by the time you start doing your, postdoc or whatever, you'll know how to do these things. And just like, yeah. So I guess I figured, yeah, I can't be the only person who doesn't find that the best way to learn stuff. And I did some research, and actually, it turns out in the educational world, it's pretty well known now. Actually, most people don't learn particularly well that way. Um, the people who do have a monopoly on our academic system because everybody in academia are by definition people who succeeded in going through the traditional approach. And so they have this huge filter bubble of being surrounded by people who all went through that traditional approach. So I guess, yeah, I kind of built the thing I wanted. And also I wanted to understand everything extremely deeply. And I felt like the only way to do that was to pick apart everything and try changing it. And as I started doing that, I realized a lot of the common beliefs about what works and why and what doesn't work and why were faulty. So it kind of turns out to be a great way to do R&D as well. And
Yeah.
I kind of end up doing it with this community of students because then we're all kind of like pulling things apart and asking each other questions. I mean, like, well, this paper says this, but if I tried this, this thing happened. Why would that be? And then,
Yeah.
you know, we end up kind of talking to the authors of the paper and they say, oh, we never got around to trying that or whatever. So it's been like a great journey that
Yeah.
we've been on as a community for quite a few years now.
Um, where did you find this first few students, and like what was that moment like, when it was you and your wife, I think you guys launched
Yeah,
this course, and how did it go from there to, as someone who's very interested in growth, I just want to know
yeah.
what that journey was like.
I mean, it's like, thank God my wife Rachel was interested as well. You know, like it started, I guess. I mean, I'd done stuff with neural nets back in my early 20s, you know, but it had been decades. I kind of put them aside for a long time and used other approaches, um, feeling like at some point they'll be back, and then I'll want to dive in. And Rachel didn't, you know, Rachel's background was more of a pure math, you know, math PhD person. So she didn't have the background in neural nets that I did. So we both decided together to, in kind of from 2013-ish, to really understand what modern neural nets looked like as at that time. Um, and yeah, as we tried to understand that together, we found, you know, we had so many questions, so many things that didn't seem very clear. We asked the kind of authors of papers about things, and they would say like, oh, that's like, you know, unpublished details that aren't available. And we just thought, okay, yeah, there's no way normal people can reproduce any of the results in these
Mhm,
papers.
mhm,
So yeah, so once we got to a point where we felt like, okay, well, we can understand some results in some reproduce some results in some papers now, and maybe even go further. We thought we'll teach people what we've learned. That was basically lesson one, you know, of part one, the first time around. And um, I'm trying to think. I, you know, I guess we just created a website called fast.ai, and it's actually just a blog. And we put up a blog post and said, we're going to teach this. And I think just there was a lot of interest
yeah,
in learning how to do that.
yeah,
So a lot of people joined that course. I think also, you know, we did it with the University of San Francisco. So the master's students were given the option to join for free.
yeah,
And so I don't know, maybe half of them or something did.
yeah,
And yeah, so we had, I'm trying to remember, maybe 100 or so students at first. And yeah, it's terrifying building something the first time. It hasn't been built before. We don't know if it's going to work. You know, we had no idea if any student would get anything out of it, if it would be a total failure. We didn't know if anybody would turn up. But the students, yeah, they enjoyed it. They said they enjoyed it. They shared their projects on the forum. We created a forum for it, and the projects were impressive. You know, so I guess when we then launched the recordings of that course as our first MOOC, we were able to point at those and say, look, here's some actual students, here's their backgrounds, here's who they are, here's pictures of them, here's the projects they made. And I think a lot of people kind of said like, oh, that person's not that different to me. You know, maybe if they can do that, I can do that too. So they gave it a go. And so, yeah, you know, even that very first course was actually really popular. And it was the only one of its kind. So if you wanted to learn deep learning with no previous background in the field, not like you had a lot of options. There was Andre Carpathy's fantastic Stanford class was online, which was very good, but it was didn't cover everything and had a bit of a different focus.
Yours was the only programming focus, and like you get to play with the neural networks within the first half
Hmm.
an hour course for
Yeah,
sure.
yeah, and it was in
Yeah,
Python, not in Octave or Lua or the other
MATLAB
languages
or
that like
whatever.
Andrew Ng's course used or Andre's course used or whatever. Yeah, so that I think
Yeah,
that helped a lot too. And
I'm
also
glad you.
using a higher level framework, we use Keras on top of Theano, which
Oh yeah.
made it, we could really, there's this thing called cognitive load theory in education, which is the idea that you've only got a certain amount of mental capacity to think about stuff. And if you're thinking about, you know, a whole bunch of ceremony to get to a point where something's vaguely working, you don't have any cognitive capacity left to think about like what the main thing in the lesson. So like by using Keras, it allowed people to use less of their cognitive capacity to like build the basic model and do the training loop. And therefore they had more cognitive capacity to understand the lesson. And so, that's always how we've done things, is really trying to focus on, yeah, leveraging higher level frameworks at appropriate times so that your brain can focus on the bit that we're actually trying to teach you right now.
Yeah. Um, Absolutely love that. I've always taught myself like programming and everything else that I've learned in my life. I don't like traditional schools, and like your approach makes so much more sense. I wish
Oh,
every subject was taught like that,
yeah,
you
me
know?
too. And now that I'm homeschooling my daughter, that's something I deal with every day, is we're always trying to find ways to teach things in context and project based and um, like for math, for example, I have her use a calculator as much as possible, which is the exact opposite of how primary school teaching is normally done. It's normally like do everything in your head or in pieces of paper. Yeah, I feel like a lot of education's upside down.
Yeah. Maybe that can be your next startup after all of this, fixing schools. You remind me a lot of like, I feel like anytime you read about how Feynman thinks about things, he was also like, let's play with it and let's learn about theory later. So it's really nice.
Yeah,
I'm
no, I
wondering,
mean he's very
oh,
inspiring role model in a lot of ways. His work on um, quantum spin and stuff that he says maybe somewhat tongue in cheek was based on his study of how dinner plates spin.
oh yeah,
It's
yeah,
nice.
yeah,
Yeah.
yeah, it makes it approachable and like anyone can do it, and it makes it more fun and less the serious thing that
Yeah.
is in it.
Also, like his way of talking about reading papers was always like saying, okay, well, I would focus 100% of my time on finding a physical analogy for the thing being described, no matter how abstract. And then I would spend all of my time thinking about the physical analogy. And he said in his autobiography that the authors of these papers would often be very surprised at how quickly they had developed an understanding of the paper and even seen holes in it. And he always felt like it's not that he was particularly smart, it's just that he used the brain's natural intuitions by putting things into a framework that allowed those intuitions to be used.
Do you do that with models?
Yeah, all the time. Like, when I'm thinking about training, I'm always imagining a little ball falling down a, bumpy surface and thinking about how to smooth it out. And um, yeah, I'm always using analogies both when I'm trying to teach and when I'm trying to understand and trying to try things.
Do you apply this to your real life? I mean, the rest of your life also, like this quick feedback and of like try things, like because like I feel like this is something I try to teach my team because growth is like that too. You don't have answers. It's like model
Right.
training. You try something,
Right. Yeah, yeah. No, I mean, exactly. So back when I ran an email company called Fastmail, it was really nice because on the growth side of things, it was all about that. In fact, as far as I know, we might have been the first company to do um, real A/B tests on the internet. So we
Oh
created
wow.
10 different versions of our homepage and put a different cookie on each one. And, I know this stuff's all very normal now, but nobody had done it at that point as far as I knew. And we tracked conversion. And yeah, it's like nice because you get that like by the next day, you can
Mhm.
see.
Like,
And in that case, it turned out it didn't really matter much at all, which was interesting. It told us like, okay, don't spend ages fine tuning our homepage because for the particular people we were reaching, doesn't seem to make much difference. And did similar things. Again, it's like pretty unheard of. Those in those days, but Google Ads had recently come out. Maybe they'd just come out. I can't remember. And we were like, oh, let's try some. And so we tried lots and gave them different URLs and tracked them. And yeah, I enjoyed that about running a consumer startup, being able to get instant feedback and try things each day. Hmm.
do you also do that in your personal life, or like when you're teaching your daughter? Do you have examples?
Um, I mean, yeah, it happens very naturally when you're teaching a family member because they'll look at you and they'll go, I'm bored, or they'll, lie down and close their eyes or whatever. So, that's, uh, you're like, okay. I, um, and I guess some people might try to push through. I definitely don't. My approach is like, okay, what I'm trying to teach here is boring. And so the problem is not I need to make my daughter listen more. My problem is I need to stop being boring. So yeah, I'll just throw it away and we'll do something else totally different. Um, yeah.
That's good parenting advice. Um, I'm wondering how you measure the success of fast AI. Like, is it like the number of users? Is it like the intrinsic mission? Yeah,
So yeah, so I've never been a fan of metrics. Back when I did management consulting,
yeah.
started 30 years ago. Um, Particularly when I joined AT Kearney,
Mm.
it, they, they were very focused on metrics, around marketing, around everything. And yeah, we really noticed though that companies that employees and managers manage to the metrics, and it really seemed to work out very well. So my approach with fast AI is like it's very much based on like talking to people, and understanding, like, and trying to form good relationships with people, and knowing that there are people who are the kind of people who will say to me, like, you know what, Jeremy, you know, that lesson didn't really resonate with me, or you know what, this API in this library, it's pretty complicated, or whatever. So, and also, to talk to people and hear stories of like, okay, yeah, we tried using your library and it worked really well, and now we've built this product on top of it. Or we've tried using your library and we couldn't understand how to do this and we totally gave up and we ended up writing something from scratch. You know, that kind of thing is the most helpful way I have of understanding what's working and what's not.
Um, I'm curious, what drives you as a person?
Yeah, I don't know. I sometimes wonder that
Sorry,
myself. It's
this interview
like
is going everywhere. But yeah.
yeah, yeah. Um, basically, in terms of like what I enjoy, for whatever reason, I get a huge amount of pleasure from learning new things, of any kind. So like I really enjoy like kind of adventure sports type things. Like, like I really enjoyed like learning to ride a motorbike extremely fast around a racetrack, for example. Like it's looks really difficult, but when you hook everything up just nicely, you like get this feeling of, this beautiful Zen feeling of everything's flying past you and you've got it under control, you
Yeah.
know,
You could
or
die
like
at any
ditto with
moment.
like,
Yeah.
skiing in France, down a double Black Diamond Run, and that's, you know, you remember not long ago, you're thinking like, I could never do that, and now you're just thinking like, everything's just hooking up, you know, and now I don't understand, I don't know why I couldn't do it, because now it's like straightforward, you know, so like, yeah, that's what I enjoy, you know, is taking difficult things that feel difficult and getting to a point where they don't feel difficult. And I think teaching helps a lot. Like often I find I can't understand something and till I try to explain it to somebody else, and then I suddenly realize, okay, I guess I do understand it. So yeah, I think that's something that really drives me, and doing it with other like-minded people also particularly drives me. So I kind of have a, you know, couple of times a week regular chat with some friends now where we like kind of read and implement papers and stuff like that together. And yeah, I definitely get a lot of enjoyment of doing that. And, you know, even when we're not chatting, we've got our little Discord group that we're, you know, bouncing ideas around. And yeah, I definitely like that.
And how does that translate into the projects that you choose? For example, like MedARC, this new
Hmm.
research work that you have. Like, is it because you didn't know, I mean, anything about the medical industry and you were like, oh, this sounds like a hard problem. Let me figure it out? Or yeah, how did it
Yeah, so
happen?
MedARC is a new project that actually a guy called Tanishq Abraham launched. Um, Tanishq is a 19-year-old about to be a PhD graduate. Um,
Insane, that guy.
and his area of expertise is using deep learning for microscopy. He's a fast.ai alum and now key part of the fast AI community. Um, and so I kind of, yeah, told him I would like to be a part of it, basically. And he said yes, which is nice. And it's, so in this case, this is an area I'm very familiar with because I started the first medical deep learning company years ago. That was called Analytic. Now, at that time, that was definitely something I knew nothing about. But it in that case, in this case, it was more about like um, if, I don't know, feeling like there's this huge gap in the amount, you know, in the amount of medical experts available in the world, and it seems like a gap that's not like can be fixed by helping the existing medical experts become much more productive by leveraging AI. And so it's more, this is more like I feel like it's something I ought to be doing. So, you know, I had a similar thing early in the COVID crisis when I discovered, much to my surprise, that basically all the science I could find and all the scientists I could speak to who were experts on like aerosol transmission of pandemics and whatnot all thought that masks would be really effective. And I did a whole bunch of research and yeah, just discovered to my surprise that that seemed to be true. It's like, okay, I feel like I should spend time studying and teaching people about this because it seems like nobody else is going to if it's not me. So yeah, definitely, I'm kind of driven partly, just quite strongly by a, um, you know, if there's some kind of service I feel that I ought to be performing, then I do that, even though, like particularly in the masks case, I didn't enjoy it at all. I did it, you know, and I didn't make any money out of it. It's just entirely, I thought this is something I should be doing. In the MedARC case, it's something I enjoy a lot, and particularly like I say, I like working with like-minded people. So the opportunity to work with Tanishq is a big part of that.
I want to ask a spicy question and then I'll come back to MedARC. I feel like I ask myself this often too. Like, um, would you be fine if anyone like built MedARC? Like in this case, it was Tanish building. He was a friend, and you joined him, and like now you guys are working on it together. Does it have to be you, or are you happy to support anyone doing it, even if it's like someone else who ultimately is the one to
Yeah,
build it?
no, it
Like,
definitely doesn't have to be me. So
Yeah.
In fact, I've got a good example of that.
Yeah.
We felt, me and my friend Hamill felt like there was a big gap, that there wasn't any easy enough to use kind of technical blogging options, like really easy to use, the kind of thing that somebody who's a chemist or a journalist or whatever can use without any technical background. So we built one called Fast Pages. And yeah, we built it because that was a gap that needed to be filled.
Yeah.
And so we filled the gap. And then some years later, um, my friend JJ and his team at our studio, now called Posit, built something better called Quarto. And so, a common response to that, I guess, would be like to dig in and try to like copy Quarto's better features and make Fast Pages better and compete with Quarto. But I was like, I chatted to Hamill about it. We're like, okay, well, we built Fast Pages to meet an unmet need. That need is now met better by something else. So we we archived Fast Pages. We put a message on the Fast Pages page saying, oh, Quarto, you should use Quarto, it's better. We built a Fast Pages to Quarto migration script that would let people switch. And now people use Quarto and we use Quarto and we're very happy with it.
I don't know if I would be as nice as you. You're definitely a better man than I am. Um, okay, coming back to MedARC, I briefly scanned the page, so I haven't engaged with it too much. But like, you are training large models. Like, what kinds of models are you training?
Well, it's very early days, Lavanya.
Yeah,
So, basically the plan, there's only
yeah,
plans at this point,
yeah, yeah.
is to train multimodal models that will
Mhm.
bring together medical imaging, um, you know, um, billing records, um, doctor's notes, radiology reports, um, medical sensor data, as much as possible. The goal being to support um, medical staff, doctors, nurses, community health workers, so forth, so that they can do their work more more quickly, more accurately, um, by leveraging models of that data.
Mm. And how do you get these models into production?
Um, we have no idea, I
Okay.
mean, that's that's hard, and it's not our area of expertise because that is all about dealing with regulatory, groups and stuff like that, which Tanishq and I are not experts at. I mean, I have a little bit of expertise there, but not. There are plenty of people with a lot more. There are plenty of lawyers that's their job. So our focus is on trying to show what's possible. So, as researchers working with academic medical hospitals, so for example, we've got a partnership at the moment with Stanford. Doctors at Stanford have a huge amount of leeway, nearly total leeway. This is part of the US medical system, as deciding how they should diagnose and treat their patients. So if they wish to use Stanford's data to build a model that then they use to help them diagnose their patients, it's not, there's no, nobody in the government can tell them they're not allowed to do that. That's they're doctors and they get to decide how to do doctoring, so yeah, so we can work with these groups to help them, help doctors do what they want to do.
Mhm.
And we can publish the results of that. And then if people decide, like, what, that would be good if other people could get to do that as well, then they can figure that out. And it's probably not going to be in America where that happens, because America is not really ahead of the game when it comes to how the regulatory system works, or more importantly, how medical incentives work. But we might well see in China or in India, for example, where there's a lot of digital health going on, and maybe a bit more flexibility around um, thinking about how best to, and also a huge bit much more of a need. There's a shortage of doctors in these jurisdictions.
Yeah.
Maybe there will be more of an opportunity to roll out these models more quickly.
Hmm. Interesting. And there you could have a much more, like, you could help them define the system, the EHR records, what they look like, because they don't even have anything today. Um,
Yeah, well, I mean, they actually have a lot, you know. So
mm,
developing nations are
yeah,
called that because they're developing.
mm,
And in fact, you know, China, for example,
yeah,
has is pretty developed at this point, but they developed more recently. So their medical systems don't have the same, you know, kind of archaic foundations that Australia's or America's do. So they have a lot of very high tech equipment, and they're connected to much more high tech digital backbones to some extent. Um, so yeah, it's, you know, for example, last time I checked, Apollo, which is an Indian group, had like the largest kind of digital health system in the world, you know, fully digital. But
oh,
there are pockets, you know. So for example, actually one of the world's largest pathology companies, Sullivan Nicolaides, is actually an Australian company, and actually um, they're, I would say, you know, I'm pretty sure would be considered by far the most advanced in the world when it comes to a digital pipeline with AI helping it, and that was all actually built in my home state in Queensland. Um, so there are interesting pockets of brilliance around the world, and hopefully, by MedARC being a very open, community-driven approach, you know, it allows us to work with those pockets of brilliance, and you know, and you know, there's a lot of brilliant people at Stanford, for example, who we can work with on these partnerships and drag along the rest of the world when they're ready. You know.
in there. I love looking at the world as like pockets of brilliance. It's such a happy way to look at the world instead of, you know, I'm going to use that for
Instead of
sure.
pits of darkness and despair in the rest of the world. I don't know. Yeah.
Oh yeah, and then I was gonna ask, speaking of that, like, there's something on your website around like you want to build an interdisciplinary team for this. Like, what kinds of people are you looking for? Do you have a strategy, or is it like, hey, if doctors want to work with us, we'll like tweak our program to that, and you know?
Yeah. My approach to everything nowadays tends to be like very community and demand driven or and availability driven. So, um, you know, we have a Discord. People find us. You know, there's, you know, so we've got hundreds of doctors on our Discord saying, "Hey, I'm X and X, I'm X. I'm in this part of the world. I work in this area. This is the data sets I have. These are the problems I'm personally interested in," and we can help hook them up together with like some PhD student who said, "You know, I'm this person. I'm at this university in this part of the world. You know, my expertise is over here." And Tanishq and I can help to coordinate these groups and supervise them, and then identify places where we can combine data sets together to, you know, or leverage a pre-trained model that we've been working on. So yeah, you really need some kind of central place for people to come, you know, and provide their problems, their expertise, their data, and someone then needs to help these groups to work together. You know, there's lots of PhD students, for example, who really want to work in deep learning. They really want to work in medicine. They can't find anybody in their local universities who know about these things, but you know, they've got people who are prepared to support them.
Right.
And you know, so we can say like, oh, here's a group that you can work in, you know, got exactly the kind of expertise you're interested in developing. So yeah, it's very iterative, you know, and I find things tend to, as long as you're in the right general space, things tend to fall out pretty nicely. You know, I've never personally, you know, as long as Fast AI has been alive, there's never been any kind of projects we've done that didn't go anywhere, because you know there's so much white space available, so much stuff that you can do. You can really pick almost anything and find lots of high impact things you can do.
Interesting. And that kind of makes me think of like you're so good at building communities. And I'm wondering what makes you so good at building communities like like even with fast AI, a couple of things that I've heard from people or like you're in there answering questions by people, no matter who it is, you know. But I'm wondering, yeah, what is your secret?
Yeah, people often ask me that because if somebody like I know people who are like that their jobs is to be community builders and they always talk about things I've never heard of. I don't feel like I know anything about this space. It's been totally an accident. But yeah, I've built lots of communities and they have all been successful. But like they were always I don't know, me trying to like just find people of a certain type that I could like talk to or who could they could talk to each other and just very genuinely talk to them, you know? So like I mean, certainly I try to pick a software platform that's as easy to use and flexible and nice as possible. And, you know, so with Fast AI, we started with discourse forums and they kind of had only just come out, but I really thought like this is a nice platform. I like using it. I think other people will like using it. Um, and then tried to like really genuinely answer every question that people asked. If there's anybody being like not particularly nice, you know, even if it's like you can't, it's not that they're swearing or maybe they're just being a bit passive. Like it's not particularly nice. I step on it very quickly. You know, it's definitely not a like, you know, freedom of speech platform where anybody gets to say whatever they like, however they want. You know, I want everybody to have a lot of pleasure in interacting with the people there.
Yeah.
Um, and if somebody's making interactions not pleasurable, I try to be understanding, but I'll send them a direct message and say, look, this message you sent, I didn't come away from it feeling happy. You know, do you feel like people would come away from that message feeling happy? And, you know, generally they'll say, like, no, I was pissed off. I wanted people to know I was pissed off. And I'm going to say, well, it sucks to be pissed off, but do you really think it helped to like make other people feel pissed off? Like, it's, you know, like, let's not go there. And 99% of the time, people will be like, yeah, you know what? I don't want to make more people pissed off. You know, you know, you're right. 1% of the time, like maybe once a year or two, there'll be somebody who's just like, I hope everybody's pissed off. You know, you know, I think everybody deserves to be pissed off. And I just like, okay, that's a point of view. I'm not okay with having it here, so you have to leave. You know, this is not what we're building and the people we're building it with. So don't come back. But yeah, so have nice people being nice to each other. I mean, I try to be really like understanding that everybody has bad days, and so time to time it's like smooth over things. People argue a bit with each other, and I just be like, let's, you know, start a three-way DM, talk to them both. It's like, look, you know each other. I can understand why you felt this way, why you felt this way, but you
Wow.
know,
So you're playing therapist there too, damn.
yeah, definitely.
It almost seems like you love being in communities. It's not like you're setting out to build a community. So it's not like I need to run three
Right.
events and like,
No, I'm
you know,
not. Yeah.
just you're just like having fun, and then
Yeah.
that invites the interesting.
Well, you know, like particularly now I'm in Australia. In San Francisco, you have a natural geographic community, you know, because a lot of people who are, you know, pretty bold and who are interested in technical subjects, and particularly AI, they tend to like head there because there's this intellectual center of gravity. On the whole, they don't head to the regional part of Queensland that I've moved to, um, which is fine because like when you have an online community, chat to people all the time, both through text and through video, and build relationships. I get the best of both worlds. I get to, you know, live by the beach and, you know, go windsurfing or swimming or whatever when I want to have a break, and then train some models and then chat to people in the AI community. And, you know, it's a nice way to be, I think. So like, yeah, like most people are not lucky enough to live somewhere where they have a local geographic concentration of people who are interested in their particular interests. But thanks to the internet, you can make that happen now.
And like that's most people. Do you have advice for like someone in middle of Ireland or like India or Australia who's like doesn't know anyone? Maybe they're still young in their careers, and not even enough people are learning machine learning in their own
Right.
class. But they're learning about large models, and they just want to talk to someone about it. Like, how
Yeah,
do they build?
exactly. So come to forums.fast.ai or come to the fast.ai Discord and just start by waving, you know,
Yeah,
and
yeah.
somebody will wave back. And it's just be like, or go to the introduction thread and say, hello, I'm whatever, from wherever. And this is what I'm interested in. And share something you've done. It's like, oh, I just built this simple little classifier after reading chapter 1 of the Fast AI book. And, share a bit of yourself, share a bit of your work. And then generally speaking, somebody's going to be like, wow, that's amazing. Had you ever considered enhancing it by doing this? Or like, oh, that's a great start. The next step would be to try this technique. And now you're having a conversation. You found yourself a bit of a mentor. And we've got so many people who have come through our course and become key parts of our community from parts of the world where they have I remember there was one woman, I think she was still a teenager from Bangladesh, and she didn't know any other women who coded, let alone who were interested in AI. And so, it was quite early on through Fast AI, she found a community of people who didn't care that she was young and a woman and in Bangladesh. They just wanted to talk about AI, and I think she ended up, after a couple of years joining a hot AI startup and blossomed, and I definitely like to provide that kind of platform where people who, don't necessarily have the resources and so forth can nonetheless, given some tenacity and belief, can find a way through.
That's such a nice thing to do for people that are
Mm,
otherwise not seen,
yeah,
or like don't have the opportunity.
yeah,
Uh, so I have
awesome.
a question. If you had more time to do research, not in medical field, and like what other field would you spend time in?
Well, I basically spend all my time doing research, so it'd be, I'd have to clone myself to find more.
Yeah.
I'm extremely interested in education. I would love to do research and product development in education around using, there's so many great academic papers in education that the ideas aren't really being leveraged at schools because schools are really limited in what they can do, you know. But there's nothing you can do about that other than like change how schools are structured, which that's going to probably take 100 years. So I think that's really interesting to think about. Like, well, what could we do differently in education? Um, yeah, in terms of applications of AI, I think medicine is certainly my number one interest. Um, and I'm definitely interested in like multimodal more generally. Um, but I'm also, really interested. I'd actually hoping sometime soonish to get back into a deep dive into NLP because it's been a few years, um, to try to really understand, like, what are the opportunities now, like particularly around like how can we fine tune these large language models better to do like to be more accurate in what they say, to guide them more, in a particular direction. At the moment, that stuff's all extremely basic. How it's being done, it works surprisingly well because the underlying idea of a fine-tuned language model is such a powerful idea. But I think there are, you know, lots of low-hanging fruit around doing that better.
Do you see a path to these large language models being used in search engines anytime soon? Because they're so inaccurate and like, I feel like with search, it's like here. 10 links that I think might work, but I'm not sure. You go and look at them and see which one. But the large language model is like, here's what I think the answer is, and I'm pretty certain, you know?
Yeah. No, I think there's a lot of room to improve them greatly. So I'd say the answer is yes. I mean, I'm not sure you should think of using them exactly the same way as you use a search engine.
Yeah.
Um, I think the UX needs a whole lot of work, and the people working on these kind of Bings and Chat GPTs and stuff generally aren't UX experts. And so the UX has been on the whole pretty poor. As you say, they're really overconfident. One of the problems is that there's a huge lack of educational materials around helping UX people understand the capabilities and constraints of deep learning,
Mm,
or helping deep learning models understand UX, which is harder
mhm.
still. So that would certainly be another area I'd be interested in doing research in, is like really taking the best ideas from the UX world and thinking about how do we build and roll out models which take advantage of the opportunities and avoid the constraints based on a really deep understanding of human computer interaction.
Yeah. And like that wouldn't make the models more accurate, but that would just frame them as what they are, which is like, these are my best guesses, and like, let's iterate.
Yeah, exactly. A bit of that, and also a bit of like not just throwing the tokens in that have the highest p values, but understanding like that this is actually an area where maybe I shouldn't just be throwing in high p value tokens, but I should be like saying like, yeah, to answer your question, um, I would be looking for things like this. This isn't something I'm great at, but here's three like queries you could click on to get back lists, which I will help you summarize, and then come back to me and we'll talk about your understanding of those summaries, and, more of that kind of using humans, using the web, using paraphrasing, using summarization, using calculation engines, together, and even multimodal, like I don't quite know what you mean. Like, here's a canvas. Could you like sketch it out? And being able to like, or like take a screenshot for me, or let me turn on the video camera on your computer, so whatever, so I can get this information.
Yeah. And that sounds really fun. Um, Cool. Let's try to end with two quick questions, maybe. The first is like, if you're not a machine learning engineer, if you're like a doctor, lawyer, someone, and you want to benefit from AI, like, where do you get started?
Yeah, so that's exactly what fast AI is meant to be. So we've got lots
Yeah.
of doctors and radiologists and stuff who have done that course. Unfortunately, we're still at a point where you need to be able to code to use these tools effectively. We're hoping to get past that point, but honestly, it still feels like it's years away. I was hoping we'd be closer by now, but we're not. So it's going to be a long journey. It's really hard to do when you're, you know, at med school or doing your residency or working as a GP or whatever. But there are lots of doctors who have done that. So we know it's possible, and they've gone on to be like world leading experts in the medical AI field. So you should expect it to be hard and to take sacrifices and to take a lot of time, but there are lots of role models that show it's possible.
And then the last question is, how has it been like moving to Brisbane from SF? Should people still be trying to move to America in general, SF in particular, or can they work from anywhere? Yeah.
It's a great question. I would say people should definitely try to spend a couple of years in SF if you're interested in this field. Um, there's a lot of things I don't like about America, like the kind of the values and the individualism, and you know, but SF is a unique place and time in history. It's like it's a collection of brilliant people who have come together with a lot of kind of common goals. Now that can and does lead to a lot of toxicity and a lot of over competitiveness. There's also a lot of great cooperation and um, fantastic communities that are building there. To be amongst like-minded people in person, yeah, it's really nice, you know. Um, but yeah, I'd say a couple of years and then get out because, I think it can also do your head in a little bit. And I think you can then, once you've got that confidence and those connections, you can then leverage those digitally. Like I don't feel like now I'm missing out at all by
Yeah,
not being in SF. But if I hadn't have been in SF, I don't
then
think I would be doing the things I'm doing now.
that's a good way to end the interview, Jeremy. Thank you so much for being here. It was so much fun.
No worries, Lavanya. Thank you.